With this video, I want to go over some of the review problems for Image 1118 and how to solve them. So the first one says, what is the pixel size when operating a 1000 line system in 9-inch fluoro mode? 25.4 millimeters equals 1 inch. So the size of the pixel is going to be the field of view, or the fluoro mode size, or the input phosphorus size, divided by the number of lines in the system, or the number of lines in the matrix. So since the answers are given in millimeters, we need to convert 9 inches to millimeters, so we simply multiply 9 times 25.4 millimeters per inch to get 228.6 millimeters. And then we divide that by 1,000 lines in the system, and the answer is 0.228 millimeters, which is answer B here. The second problem says a radiograph of the knee is taken at 60 kVp, 20 MAS. The overall receptor exposure is acceptable. However, the contrast is high and bone appears white and underpenetrated. Which of the following technical factors represents a change that would improve this image and maintain the same overall receptor exposure? So notice we're asking about penetration, and so we want to go up in penetration, which means we want to go up in kV. We usually go up in kV by 15%, and 15% of 60 is calculated by multiplying 60 times 1.15 to get 69 kVp. So if we look at these answers, we have a couple of them that are 69 kV and a couple that are 50. We can't use the 50 because that's going to actually increase the contrast. So we want to go to 69 kV, and now we ask which of these would have the same receptor exposure. And so we've gone up 15% kV. We need to decrease the MAS by half, and so we want to go down to 10 MAS, and that makes B the correct answer for that one. The next one says a Bucky chest radiograph was taken using an 8:1 grid at 110 kV and 4 MAS, results in satisfactory receptor exposure. What MAS should be used to maintain the same exposure on the next radiograph if a 10:1 grid is used? So if you remember our large formula or fraction for receptor exposure, in the numerator we only need to use the things that are in the problem, and 4 MAS would be in the numerator on one side because this is the one exposure, and we're not going to worry about the kV because it's not going to be what we're asked for. We're just using a change in MAS. So just the 4 MAS on top, and the denominator of that equation has the grid factor. So 8:1 grid factor for the first exposure is, the grid conversion factor is 4. So we want to equate that exposure to a new MAS that we don't know yet with a grid conversion factor of 5 for the 10:1 grid over here. And if we solve for x for the new MAS, we get x equals 5 times 4 over 4, which is 1, which would give us an answer of 5 MAS, which is B. Next we have a set of factors, and I want to know which of these sets of exposure factors would give the greatest receptor exposure. And so in this situation we're going to multiply, or use our formula again, where we have MA and then the exposure time on top, multiply these, times the kV factor. And for this we use 1 for 80 and 2 for 90. So when it's 80, we're going to use a kV factor of 1, and when it's 90, we use a kV factor of 2. And then we multiply by the speed up here, and and then divide by the grid factors down here, grid conversion factor, and by the SID twice since it's squared. Okay, so we do that for each of these, and the first one, we multiply 250 times 0.2 seconds times 1 for the kV factor times 100 for the speed, divide by 4 for the grid, divide by 40 twice for the SID, and you get 0.78 for A. For the B, we have 300 times 0.02 times 2 for the kV of 90 times 200 for the speed, divided by 4 for the grid, divided by 60 for the SID, and you get 0.16. For C, we have 250 times 0.2 times 1 for the 80 kV factor times 100 for the speed, divide by 6 for the grid factor, divide by 40 for the SIDs, you get 0.52. And then for the D, we have 300 times 0.02 times 2 for the 90 kV times 200 for the speed, divide by 4 for the grid, divide by 60 for the SID, and you get 0.16, with the answer being A as the highest or greatest receptor exposure. So that's the calculation for the first 4 of these review problems.